Hey, so today we will talk about the evolution of the knowledge graph and the meaning of the knowledge graph in artificial intelligence agents and how they connected to each other and so on. So, for sure, Google started the revolution with the document things, not strings, and all those things. But even before this, we had a concept of semantic web, and we started this knowledge graph story from the static graphs that, was fixed, statical. They haven't changed over the time, and we will see that evolution of the knowledge graph is tightly coupled to the time. So this static thing that you could query, reason on top, and it was good enough. But at some point, we built more and more complex systems, and we came up with the dynamic graphs that are not just static, they discovered the new facts, had the regular updates, we get much bigger data, and this data required maintenance, and as a side effect of dynamic graphs, we get the engineering around that actually really focus to build this, systems that manage the graphs, updated the data, and all of it. And but in these dynamic graphs, we usually ignore the time. And in some point, we came with the temporal aware graphs or temporal graphs. And temporal graphs, they really interesting. And we have a couple of different temporal aware graph, but it's a first point where we really made the time as a part of the graph. It's a structure or some properties, but now we have the time as a first citizen in the graph. And I made a lot of videos about this. How to handle the time, should time be this part of the structure, should it be relations and all those things. You could read some Medium articles about the time, and it's already quite complex, and it's not so easy to handle the time in general. And then the last point in this graph revolution was to make together with the entities the events. So the capture time not as a parameter, but capture time with all the richness of complexity as a nodes. So we have the events that describe how systems change over time. And this event could capture not only the temporal part, but some data around the event, who was involved to this, where it's happened, and so on. And in the event-oriented graphs, you have the events as nodes, and you have the regular entities as nodes, and quite often events explain how the entities evolve. And one interesting case of the event-oriented graph, it's the entity state systems, where you have the entity, couple of states and events that describe how the entity evolved over the time. And the last point in our journey of the evolution of the knowledge graphs, actually it's LLM empowered or artificial intelligence empowered knowledge graphs, because right now we have a lot of topics how to use the LLM to construct the graphs. And if you take all the graphs like dynamic and static, we need only the entity recognition process and relation process. So we need to recognize the entities in unstructured data, and we need to recognize the relations between these entities. And this relation discovery could be quite complex, and we could have the complex reasoning that help us to infer new relations in a graph and all those things. And for sure, even for these statical graphs, we have quite interesting graph-oriented networks, the graph-oriented neural networks that help us to discover and infer relations and so on. But when we talk about temporal graphs and event graphs, it's mean that together with the entity and relation extraction, we need to build quite sophisticated process that will recognize the events and time and extract the temporal component from unstructured data. And it's really complex thing, because quite often people talk about the time in reference to some other events, and this entity and event recognition. It's lay on the foundationals of the artificial intelligence, uh, distinguish between the episodic and semantic memory. So the event graphs actually is the episodical memory inside the semantical structure. And it's a most complex type of LLM extraction. It's extracting of the time and temporal reasoning. And we have the temporal reasoning, temporal logic, and a lot of things around the time that I quite keen to talk with you. And you know, a lot of LLMs actually struggle to understand the time, and we still need to have the specialized systems to make so. So that's all that I was keen to explain to you today. So to every stage of the evolution of the knowledge graph, we have some sophisticated processes that LLMs and machine learning models could help us, from the entity recognition and relation extraction to the extraction and temporal reasoning to the event extraction that actually fit to the question, is it episodic or semantic memory? And if you're working in this space, I keen to meet with you in person and have a warm talk about the future that we could have for the artificial intelligence memory. See you next time. Choose.